So in this video I'm going to run through the questions for quiz 8. This week you're revising CC8, which is the acids topic. It is going to be a big part of your mock, so it's really important that you take the time this week to properly revise it. And then you've got a little bit from CC16, which is our current topic. The first question here, I'm just going to scroll down to this bit. This came up 2 years ago, and if you look at the examiner's comments, it says it was very, very poorly answered. It's not something you've specifically learned, it's kind of an application style question. So they say that metal Y is reacting with an acid, and you get bubbles at the start to show hydrogen's being produced and the reaction's taking place, but then the reaction just stops. You've still got lots of metal left. You've still got, it says, an excess of sulfuric acid. So you've got lots of acid, you've got lots of metal left, but for some reason the reaction stops and they want to know why. Again, the reason it's going to stop is the metal will react with the sulfuric acid and will form metal sulfate, but the metal sulfate forms around the metal itself and it stops the rest of the metal from reacting. So it's kind of like you've got your piece of metal and then all around the outside you get this layer of metal sulfate, and the metal sulfate stops the rest of the metal inside reacting with the acid. So essentially you have to describe that process. Again, not something you specifically learned, but something that they wanted you to try and come up with yourself. Was probably one of the hardest questions on the paper. The next one, explain the term weak acid. So weak acids partially dissociate, so they produce less H+. You have to mention H+ when you're describing a weak acid or a strong acid. This should be relatively straightforward. This part here, why does pH increase? Anytime you're asked about pH, you have to talk about H+. So I know if I was marking this for you, a lot of you would say, oh, pH increases because the acid's being neutralized and it's becoming more alkaline, and alkalis have a pH above 7. That's the kind of common student response. If you don't mention H+, you're not getting the marks. Okay, so yes, you are adding an alkali to the acid. Okay, so then you have to say the H+ reacts and you have less H+. So the H+ is reacting, the H+ is being used up, and you've now got a lower concentration of H+. So always tell me what's happening to H+ when you're asked about pH. This one, you just need to complete the equation. You need to know the formula of sulfuric acid. Okay, you already learned that a sulfate ion is SO4 - 2. To turn sulfate into an acid, acids have to have hydrogen. If it's got a -2 charge, that tells you need to add 2 hydrogens, H2SO4, okay? But if you're writing down a formula that doesn't have H, you are not writing down the formula of an acid. Copper sulfate then, copper has a Cu+2 charge, okay? I can figure that out by looking at the formula of copper carbonate. Carbonate is -2, copper is +2. So then copper sulfate is going to be CuSO4. You get 1 mark for each formula. This I think should all be relatively straightforward. This one here, 2 observations that show that a reaction is finished. Again, look at what you're making, all right? So you're making carbon dioxide. Carbon dioxide is a gas. Whilst the reaction takes place, you're going to see bubbles. When the reaction finishes, the bubbles will stop. The other thing you can see, you can see here from the picture, copper carbonate is a solid, and initially the copper carbonate will react with the sulfuric acid and the copper carbonate will disappear. When the reaction is finished, the copper carbonate will have nothing else to react with, and the copper carbonate, which is a solid, will stop disappearing or stop. Now you can't just say that the solid stops reacting. What do you actually see that lets you know the solid has stopped reacting? It's because it stops disappearing, or you can say it all just gathers at the bottom, or you can say it makes the solution turn cloudy because it stops disappearing. Anything along those lines, but it's what you're actually seeing, not just what's happening within the reaction on a particle level. The next one at 1C, this is such a touch of a 6 marker. If you look at the mark scheme, it's really, really basic. How would you obtain a solution of copper sulfate from the mixture, and how would you obtain pure dry copper sulfate crystals from this solution? Okay, so when you carry out this reaction, this is what you end up making. Okay, so this is the reaction here, and in the flask at the end, so if I redraw this, in the flask at the end, you're going to have copper sulfate, you're going to have water, The carbon dioxide that you're making is all just going to have bubbled away, so you don't need to worry about the carbon dioxide, it's already gone. But because you keep adding copper carbonate, you add it in excess, at the bottom you're also going to have some copper carbonate that hasn't fully reacted. And they're asking you, how do you get copper sulfate by itself? So you need to get rid of the copper carbonate and you need to get rid of the water. Okay, the copper carbonate is insoluble. To get rid of it, you just use a filter. So just describe that process. So you put a filter paper into a funnel and you filter out the copper carbonate. Once you get rid of the copper carbonate, you're left with CuSO4 and water. CuSO4 is dissolved in water. How are you going to get rid of the water? You heat it, you evaporate the water, and then you let the copper sulfate cool. So you get larger crystals. Okay, you'll see the answer on the mark scheme, but it's not difficult chemistry. It's just describing filtration and evaporation. The next one's actually a really nice 6 marker as well, as long as you know your reactions. So you've got magnesium carbonate and you've also got magnesium, and you're going to react both of them with sulfuric acid, and you want to test the gas products that are produced. Okay, so what you need to know, again, if you don't know this, you are going to be in trouble, but you need to know that a magnesium carbonate, it is a metal carbonate, therefore magnesium carbonate is a base. Okay, and if magnesium carbonate is a base and you're reacting that with an acid, H2SO4, you are going to form a salt. Okay, now the salt I'm going to form is going to be magnesium sulfate. It's the metal from the base and then the ending from the acid. Magnesium sulfate, you also form water, and in this case, because it's a carbonate, you're going to form CO2. I think that's already balanced. Carbon, 3 and 3. It is already balanced. Okay, now if you're not comfortable writing that simple equation, you can write it in words. Write magnesium carbonate plus sulfuric acid. So they're telling you, you need to know the salt, magnesium sulfate. It forms water and it forms carbon dioxide. And then they want you to say what you would see. Okay, so what are you going to see in this reaction? So this here is a solid. Okay, so you'll see that solid will disappear as it reacts. You're forming a gas, so you're going to see bubbles. Okay, and then they want you to know how can you carry out a test to identify the gas. So you need to know the test for CO2, and you're going to say lime water turns milky. So in a full sentence you'd say bubble, the gas produced through lime water, it will turn milky to show it's CO2. And the next one, they just want you to use magnesium. Now magnesium by itself is just a metal. So now you need to know what's formed when a metal reacts with an acid. When a metal reacts with an acid, you still form a salt, but this time, instead of forming water, you just form hydrogen. All right, so if you look at what's actually happening here in these reactions, the metal here just swaps places with the hydrogen, and the metal just swaps places with the hydrogen. In this case up here, the hydrogen was then able to combine with oxygen to form water, and you were left over with CO2. But here, the hydrogen that you displace has nothing to combine with. There's no oxygen, there's no nothing coming from the metal, so your only product is going to be H2. All right, so that's going to be your equation. Again, if you're not comfortable with symbols, you can write it in Word. Again, what are you going to see? That metal is again going to disappear, so you're going to see that solid disappear as it reacts. Again, you're forming a gas, so again you're going to see bubbles, but this time the gas is hydrogen. How do you test for hydrogen? You you insert a lit splint and you hear a squeaky pop. Okay, so you need to know your gas tests. You also need to know what happens when you react a metal carbonate with an acid and what happens when you react a metal with an acid. Over here, why is this acid described as a strong acid? Again, weak acids partially dissociate, strong acids fully dissociate, but you have to mention H+, so you're going to say fully dissociate to produce lots of H+ ions. The next one, you're starting off with 1 centimeters cubed, you're ending up with 10. I can say I'm diluting by a factor of 10, to go from 1 to 10, diluting by a factor of 10, and each time I dilute by a factor of 10, the pH increases by 1, giving me a new pH of pH 3. Again, this one, state and explain how the pH changes as magnesium hydroxide is added to the dilute hydrochloric acid. So magnesium hydroxide is a base, you're adding it to an acid. The acid is going to start off with a low pH, and as you add the base, the pH is going to increase, and the pH will then be above 7, so you're going to go past the point of neutralization if you keep adding magnesium hydroxide. Initially you'll get to a point where it's totally neutral, but if you keep adding magnesium hydroxide, and it says here you're adding it in excess, so you are adding more than you need, you are going to go above pH 7. And then again, if you're asked about pH, you have to mention H+, okay? So magnesium hydroxide is an alkali, and it's going to provide OH- ions. So you're going to say the OH- ions react with H+ ions, and then that means the concentration of H+ ions decrease. And if the H+ ions are decreasing, that is why your pH is going to rise. Okay, less H+ makes it less acidic, means the pH is going to rise. I think on the mark scheme you don't even need to mention OH-. I think they just say that the magnesium hydroxide reacts with the H+ ions, but tell me that the H+ ions are being reacted with, therefore there are less of them, and it's because there are less H+ ions that the pH is able to increase. The next one here, universal indicator paper, it will just, you've used this before, it just changes color depending on the pH. So you look at the color change, and then you need to compare the color to a pH chart. So when you would have done this in year 10, you were given these little strips of universal indicator paper, and you put a little bit of the solution on them, and they changed color, just say it turned blue, and then you had this little chart, and you looked at the chart and you saw, oh, if it's this shade of blue, it must be pH 9, and if it turned purple, you were like, oh, if it's this shade of purple, it must be pH 13. Okay, so you have to mention that you're going to compare it to a chart. And then up here it says, why would litmus paper not be a suitable indicator? So universal indicator paper down here goes through a range of different colors. There's like 14 different colors to represent the 14 numbers on your pH scale, whereas litmus paper only has 2 colors. It's either red or it's blue. If it's red, it's an acid. If it's blue, it's an alkali. But it doesn't tell you how acidic it is. So we know acids have a pH less than 7. It will turn red if it's got a pH less than 7, but it could have a pH of 1, or it could have a pH of 5, and it's still going to turn the same color. Same with an alkali. It'll always turn blue whether the pH is 8 or whether the pH is 14. So it will tell you if it's an acid or an alkali, but it doesn't give you exact pH. So you'll explain this by saying litmus paper only has 2 colors. It can tell you if it's an acid or an alkali, but it doesn't tell you how acidic or how alkaline it is. You plot a graph. They even do the label the axes for you, so that shouldn't be a problem. State the name of the salt formed, aluminium oxide and hydrochloric acid. So you take the metal from the base, aluminium, you combine it with the end of the acid, it'll be aluminium chloride. It's a neutralization reaction. Over here, this is the same question we had already, the same answer. This ionic equation, we are going to spend more time on ionic equations probably after Christmas, but I will just run through how to do this, okay? If it's an ionic equation, you need to show ions, all right? So this is an ionic compound, this is a covalent, this is an ionic, this is a covalent. And ionic compounds contain ions, whereas covalent compounds typically do not. That's what we've seen when we looked at these reactions in chapter 13, when we looked at displacement reactions. However, what I didn't tell you then, because it wasn't relevant, is if it's ionic but it's solid, it's not going to split into ions. It will only split into ions if it's ionic and it's aqueous or liquid. Okay, so here, magnesium oxide, yes, it's ionic. Yes, it's made of ions, but because it's solid, it's not going to split into those ions. The next bit, yes, it's covalent, but in this case, it's an acid, and acids do contain ions. There's your exception, okay? Covalent molecules, we don't normally split, but if it's an acid, okay, you're told here it's an acid, acids contain ions, they contain H+ ions. And if I'm putting a positive charge on hydrogen, I'm going to have a negative charge on chlorine. The big two refers to the H and to the Cl. I get to the other side, it's ionic, and this time it is aqueous, so it will split into ions. Magnesium's in group 2, it's got a +2 charge. Chlorine's in group 7, it's got a -1 charge. There are 2 chlorines, so I put the 2 before the chlorine. Okay, I'm not going to put it in front of the magnesium because the 2 is not with the magnesium. And then I get to the end, H2O is a liquid. It's covalent, it's not an acid, so I just leave it as H2O. Anything that's the same on both sides will cancel, and that is your ionic equation. But as I said, we are going to spend more time doing lots of examples of this after Christmas. These are the cracking equations that we looked at this week. You just need to make sure things balance. 10 carbons on the left, you need to have 10 on the right. You currently only have 4, so X there must be 6. 22, you've only got 8 so far, so you must have 22 minus 8 is 14. C6H14. If you're starting off with 25 grams, you are ending with 25 grams. This one here is slightly harder. Okay, you've got 15 carbons. You so far have got 8 and 3 is 11, so you need to get another 4. So your temptation there might be, oh, it must be C4, but look, you've got a big 2 in front, and if I put C4 there, I'd end up with 2 multiplied by 4, I'd end up with C8. So because I want 4 in total, it's just going to be C2. All right, so if I add this up, 8 and 3 is 11, and 2 times 2 is 4, 11 and 4 is 15, now it matches. 32 hydrogens, I've got 18 and 6 so far, which is 24, so I need another 8. Again, if you just write H8 there, you're going to end up timesing it by 2, so it's going to be H4. Then 2 4s are 8 and 6 is 14, 14 and 18 is 32, so just make sure at the end it all adds up. The one that most likely needs to be cracked, all right, so if we look here in grey, we've got the relative amount and then the demand. You've got loads and loads of fuel oil, you've got lots of it, but it's not in demand. So fuel oil is the one that's going to be cracked because you've got lots of it, you don't need it, so let's turn it into something else. Let's maybe turn it into petrol, which you've got very little of and you've got lots of demand for. These are more of the same. And then the last one, this is so easy. If you look at the mark scheme, you look at this kind of model answer for 5 to 6 marks, there's really not much in there. All you effectively need to say is when you burn hydrocarbons, you could also end up burning sulfur. When sulfur reacts with oxygen, you form sulfur dioxide. Sulfur dioxide can dissolve in rain or dissolve in the clouds to form an acid, and then tell me what acid rain can do. So it's acid rain can corrode limestone buildings, it can be harmful to wildlife, it can affect, kill aquatic animals. If you look at the mark scheme, there's really not that much detail required to be able to pick up 6 marks on this. You don't need to be able to explain how it forms the acid. You just know SO2 dissolves in rainwater, forms an acid, leads to acid rain. You don't need to talk through the steps in that process in order to get your marks.